Very good afternoon, friends. Today we'll be discussing the topic on Karnaugh Maps, which is the very important topic in the digital electronics or digital system design. Especially this concept is designed for VTU syllabus for the third semester students. Now we'll go for the definition of the K-map. Hence, when we do with various theorems and various formulas, it takes a lot of time. And to derive with the very simplified expressions, a lot of time is wasted. Hence, K-map is a wonderful technique or is a pictorial method where you can represent all your letters in the form of the table, okay, with different kinds of variables and arrive at a very simplest of simplest expression. The main motto or the advantage of getting the reduced simplified expressions is that the number of gates can be reduced, uh, which arises to reduction in the cost also. So that's the main advantage of using the K-map in our study. Then we'll move to the further this one. So while performing the K-map or solving the problems on K-map, you have to go for various steps. First one, select K-map according to the number of variables. So whether it is a 2 variable, 3 variable or 3 variable. Because as the variable goes on increases, the number of cells also goes on increasing. And you have to see whether the problem is given in a SOP form or POS form. That is sum of the product or product of the sum. So if it is a mean terms, we represent using a small m and max terms using a capital M. So if the things are given in mean terms means we use ones, and if you are using the max terms, then we use the uh, digit. Okay, this one, what you can say, 0. So as a SOP formats, we're using 0, and in the POS form, we use ones. So make rectangular groups containing total terms in power of 2, like 2, 4, 8, except 1. Okay, so this is how the steps are to be followed. Then we'll see how to calculate the number of cells based on the variables. So in a graphical method consists of 2 raised to n cells. When cells is calculated by the formula 2 raised to n. So if the number of variable is given 1 means cells will be 2. If it is given 2, 2 raised to 2 will be 4. So cells is nothing but 2 raised to n, that will be 4. Okay, so this is the first what you can say given for the um, a two variable K map. Okay, a two variable K map, as we can calculate the cells as given in the formula 2 raised to n. So n is nothing but 2. So 2 raised to 2. So 4 variables you need. So which can be arranged as 0, 1, 2, and 3. Okay, the two variables are y and z. Okay, that is so n is a y is a one variable and z is the another variable. So here on the left side, if you could see, okay, to derive at the literals, we use y bar and y, and here z bar and z. Okay, and finally we arrive at the simplified expressions. This is a two variable K map. Next, we go for a three variable K map. Okay, so we're using three variables like x, y, and z. Okay, x will be on the one side, y, z will be on the another side. So we are representing just like a what you can say a truth table. Okay, so if variables are 3 months, we are getting almost 8 cells. Okay, 8 cells are arranged in the form like 0, 1, 3, 2, 4, 5, 7, and 6. Okay, see the cells are arranged in this manner, and wherever the terms based on the SOP or POS, we put those cells and we group them. Okay, so this is for the three variables. Okay, and you can see over here on the left side, you could see x. It is the one time represented as 0, that is x bar, and one another time is represented as x. Okay, if you could take the yz variables, they are in the form of 0, 0 means y bar, z bar, and in the second, the y bar and z, and in the third yz, and in the last yz bar. This is how we represent the cells for a three variable K map. And finally, we move to the one more category, that is four variable K map. So that is also calculated with the formula cells 2 raised to n, where when n is nothing but 4 here, as we're using four variables like w, x, y, and z. So we'll be getting 16 cells. So the number of cells has increased because variables are also increased. So the more the number of cells, we get more number of groups, okay, such that we get very simplified expressions. Okay. Now, when you could take the wx, they are represented using 0, 0, 0, 1, 1, 1, 1, 0. Similarly, for yz, 0, 0, 0, 1, 1, 1, 1, 1, 0. This is how it goes for a, what you can say, the two variable, three variable, and four variable. Now we come for the rules for framing the groups or this grouping of cells in a K-map. So which is collected from the survey AC projects lab view and minimization. So first rule will go, group may include any cell containing a zero. Now see, if you are grouping for max terms, means only max terms should be grouped. If you are grouping for mean terms, means you should group for only mean terms. So I can't group one and zero. So it's a wrong procedure. Okay, you have to group one and one. That's the right procedure. Okay, then we'll go for the second rule. Groups may be horizontal or vertical, but not diagonal. Okay, see, if you could see the first picture over here, the groups are made diagonally. This is the wrong representation of the groups, which is not a correct way of what grouping the cells. It's a wrong way. But you can group them. If you could see the picture over here, the groups may be done the horizontally and vertically. It's a right sense of grouping the cells. That is the second rule you have to follow in the K-map. And the third one will group must contain 1, 2, 4, 8, or in general 2 raised to n cells. So how many number of um, groups you may form? So based on again the formula 2 raised to n, if n is 1, so 2 groups can be made. If n is 2, 4 groups can be made. So this is how they have given in the, what you can say, group of 4. Then this is in the fourth picture, if you could see, it's a wrong way of representation. Then finally, each cell containing one must be at least in one group. Okay, if you want to group, there should be at least one in the group. Okay, finally, will come groups may overlap. Well, why do we overlap? To the basic purpose of overlapping is to group all the cells living not ones or zeros in the group. So none of the ones should be left what ungrouped. Every should be grouped. So we should, our preference should be always, it starts from the octet, then from the octet, then from the we can go for the quadrature, then for the pair. Okay, if the octet groups means if there are 8 ones, we can group 8 ones, then we can group for the quadrature, then we can group for the pairs. This is how we have to. If you could see the first image, which is the right way of grouping, you can group of 4 cells of ones, that is one group, and another you can overlap with another 2 ones, that is this. So this is the right way of grouping. Okay, but if you could see the second image, which is a wrong way of grouping, unnecessarily has created the 3 groups, which leads to the more expressions. Instead of that, when 4 ones are there, we can make it as one, and another 4 we can group. So this is how, so groups not overlapped. Okay, we need to overlap and see that we get the minimum expressions. So, and finally, we come to the last rule of the group. This is uh, a three variable which is having 8 cells. Okay, you can group the in the um, topmost cell and the bottom cell. Okay, you can group in this way, top cell and bottom cell, and you can group in the leftmost cell and the rightmost cell. So I can't group this second and third, okay, which is the wrong way of grouping. They should be at extreme corners, whether it may be a top and bottom cell, extreme top and extreme bottom. or it may be like in the horizontal or vertical, but it should not be nearby. Okay, I can't group nearby, I can't group diagonally. Okay, so this is the last rule of the what you can say, uh, the grouping of cells. For some more videos, we'll see in the next class. Thank you.